These explanation questions can be really tricky because you have to be able to understand that just because a statement is true doesn't mean it's going to be the answer.
Pooja, welcome back to the MCAT podcast. How are you?
I'm good. How are you?
I'm okay. Still reeling from last week. Those penicillin and serine and all of that fun stuff kind of took me for a ride. So I'm hoping this week's a little bit gentler.
I believe in you. I think you can do it.
All right. In between passages, is there any ritual that you like to do or tell students to do to like, okay, that passage is done. Whatever bad juju, bad mojo I got from that passage, I'm leaving it and I'm moving on with good feelings.
You know what? I'm really glad that you asked that because I actually like to do my little ritual every 3 passages. And the last passage you did was passage 3. So in terms of timing, we're like right on the money of what I would be doing. But what I like to do is I like to, first of all, look away from my screen, because if I'm staring at like a screen for 90 minutes straight, my eyes are just going to start tearing up. I'm going to get all like blurry vision. Like there's no point in that. So I look away from my screen and I take 3 deep breaths. And every time I breathe in and out, I try and like clench my fist, close my eyes, and just not think about anything except for like contracting everything I can, right? And then when I exhale, it's just a huge relief, right? Releasing everything as much as I can. I do that 3 times, and by the time that's all done, I feel relaxed and ready to go into the next passage. That's what I like to do. It's a little time consuming, so it takes like about 10 to 15 seconds usually for me. So I like to do every 3 passages as opposed to every single one.
Yeah. It's interesting. There, many years ago, when I first started the podcast, I had a physician on who dealt with burnout and stuff like that, and we did a very similar type of breathing exercise where you take a deep breath, you tighten everything, and then like starting at your toes, just relaxing little by little. You relax your feet, and you relax your calves, and then you relax your thighs and your butt and your abs, and then up all the way through all of your muscles. So definitely a nice little breathing exercise to do. Yeah,
no, it's awesome. It's a really good thing to do, especially during meditation. So like, I don't know if you're into like Headspace and stuff, but like all of those types of podcasts that sort of guide you through breathing, they often tell you to relax everything, like contract everything and then relax everything one by one. So it's definitely something that I recommend to people.
We get to passage 4, and I brought this up right before we hit record, and I was like, uh-oh, this looks intense. How do you avoid that sort of like immediate negative reaction? Because I'm sure that doesn't help.
Yeah, no, it doesn't help, but I think you can change that reaction from, uh-oh, this looks intense to, oh, this looks intense. This is going to be scaled very nicely in my favor. You know what I mean? Because like if a passage seems hard or a passage is difficult, there's a good chance that either the scale will work in your favor or the questions aren't going to be asking a ton about it, right? I've noticed that a lot of times in the MCAT, they pair easier passages with harder, more intensive content-based questions, and harder passages that are more stressful and overwhelming with more basic questions that don't rely a ton on understanding, or at least have answer choices that are really conducive to elimination. Wnt proteins are secreted signal molecules that act as local mediators to control many aspects of development. Wnt's are unusual as secreted proteins in that they have a fatty acid chain covalently attached to their N-terminus, which increases their binding to cell surfaces. Wnt's can activate the intracellular signaling pathway, the WNT/Beta-Catinin pathway. The WNT/Beta-Catinin pathway acts by regulating the proteolysis of the protein beta-catenin, which functions in gene regulation. An experiment was performed to test the effect of beta-catenin phosphorylation on the rate of degradation.
What? All I thought about when you were trying to read this WNT, whatever this is, with the way you pronounce it was like sweet house music.
Oh man, that's so funny.
And every time you read this passage, that's what you're going to think about now.
Oh yeah, 100%.
All right. So again, I was thrown off by just looking at this passage. And now we go through the first paragraph, and I'm even more scared because I have no idea what I'm reading.
Right. And you don't need to know about Wundt's proteins, and you can tell because I can't even pronounce it, right? If it was MCAT relevant material, I would have known how to pronounce it and tell you guys, yeah, it's a party up in here. But I think one of the biggest things to remember is sort of like what we talked about in our last passage, but stay rooted in what is MCAT relevant. And if there are unfamiliar terms that keep getting introduced, just highlight it and know that you can go back to that paragraph if it shows up, right, in a question. So if the characteristics of the Wundt protein shows up, then we know to go back to paragraph 1. We don't need to memorize or etch into our brain the specific details about it that are being sort of spilled out to us in this paragraph, right?
Yeah.
So in terms of what I would highlight, all right, like this WNT protein, it's a subject of our paragraph, so highlighting that would be helpful. We're told that it's a secreted signal molecule, so I'm like, all right, secreted signal, I know what that is. It's a signal that's secreted. That's MCAT relevant. Let me highlight that. But then we're also told about something that makes it unique. And the reason why it's unique is MCAT relevant, right? So I would highlight that it's unusual. And I would also probably highlight fatty acid chain. Okay. And the consequence of it being a fatty acid chain is also kind of relevant because we're told that it increases binding to cell surfaces. And those are all things that as MCAT students, we can understand. So highlighting fatty acid chain, binding to cell surfaces, those are things that are fair game. In terms of the rest of this paragraph, it gets really into the biochem sphere of things. So recognizing that pathway, like the name of it, highlighting that name can be helpful. Just so, again, if you need it, you can go back to it. But I wouldn't spend a ton of time on that piece, right? Towards the end of this paragraph, though, we get one of my favorite phrases to ever see in a passage, which is an experiment was performed. And the reason why I love it is because I'm immediately told by a phrase like that the rest of this paragraph is probably going to be talking about the experiment. So I need to shift the way I'm thinking about this passage now to not just focusing on like the content, but also in like the bare basics of what an experiment involves, right? The hypothesis, the methods, the results, etc.
Yeah. Interesting. Okay. So it should be a little flag that goes up.
Absolutely. So once you see that experiment was performed, I'd probably highlight effect of beta-Catinin, phosphorylation, and probably the phrase degradation. Mouse cell cultures were treated with radioactive P-labeled phosphate ions in order to determine if the degraded beta-Catinin was phosphorylated or not. At various intervals, 5 milliliters of cell solution were collected and fractionated with the aid of centrifugation to separate cytoplasmic contents from cellular nuclei. The separated mixtures were then assayed for the presence of phosphate. Assay results are summarized in Figure 1.
All right. And then we have this pretty little figure. How much time do you spend, again, kind of, we talked about it in the last passage with looking at a figure. Do you look at it? Do you not look at it? Here's more of a graph as a figure versus structure. How much time do you spend here pre-going to questions?
Yeah, I mean, I think that because, like, in contrast to our previous figure, which is just straight up like a diagram of something, there's a little bit more information that we get here. So I wouldn't spend a ton of time on it, but being able to recognize what's being shown here and in what types of questions would I want to go back to this figure is important, right? So based on like just taking a brief look at the caption can be helpful, right? So it's very clear that based on the caption and based off of a preliminary scan, there's some sort of contrast in cytoplasmic levels of labeled phosphate, right? And there's a drop in that labeled P. And that's pretty much all I would take from it. Okay, great. One other thing I'll mention, in terms of our second paragraph, there are a couple of things that I would think. Yeah, so in terms of our second paragraph, I would probably note that, again, globally, this paragraph is talking about the methods. So if there's any questions about the experiment, I would mentally note, all right, I'm going to go back to paragraph 2. In terms of what I would highlight, I'd probably note that there's a radioactive P-labeled phosphate, right? That's the key thing that we're sort of inserting. into our mouse cell cultures. And in terms of our methods, we get centrifugation, and we're looking at separated cytoplasmic contents from the nuclei. So that gives us a good framework upon which we can understand the figure a little better. And when we go back to it, understand what it's going to be showing us.
Yeah. Okay.
Okay, cool. So now on to paragraph 3. The degradation of cytoplasmic beta-catenin depends on a large protein degradation complex, which binds beta-catenin and keeps it out of the nucleus while promoting its degradation. Intact beta-catenin accumulates and translocates to the nucleus. Once in the nucleus, beta-catenin binds to its receptors, displaces the co-repressor Groucho, which is hilarious, and acts as a co-activator to stimulate the transcription of Wnt target genes. In the absence of Wnt signaling, most of a cell's beta-catenin is located at cell-cell junctions where it is associated with cadherins, which are transmembrane adhesion proteins. The beta-catenin in these junctions helps link the cadherins to the actin cytoskeleton. Any beta-catenin not associated with cadherins is rapidly degraded in the cytoplasm. How do you feel?
I feel lots of anxiety.
This paragraph is overwhelming. I'll be completely honest with you. Like, I read this and like, I'm not even taking the MCAT anymore, but I was like, oof, that is a chunk of text there.
Yeah. So you have these large protein degradation complex that binds to beta-catenin, keeps it out of the nucleus. But if it's not degraded, then it's going to accumulate, translocate, get into the nucleus, and then it talks about what's happening. So it's like two separate things, it seems like.
Yeah, that's totally right. I think being able to, I think one of the biggest things that what you sort of did exemplifies is the benefit of highlighting once you've read the entire paragraph. Mm-hmm. Because I think when you first start reading a paragraph, everything will seem really important. And that'll be the classic scenario where students will find themselves highlighting the entire text because they think it's important. But being able to recognize that there are like specific chunks of information provided in this paragraph can help you sort of break it up and figure out what to highlight accordingly, right? Yeah. So you're totally right. And that the first piece of information that's present is the idea of degradation complexes, right? So it's sort of talking a little bit about what's going to be influencing degradation, right? So there's this complex that keeps it out of the nucleus and thereby promotes degradation. So highlighting something like degradation complex keeps it out of the nucleus, or some combination of that can be really valuable there, right?
Yep.
And then the next thing you can highlight is the phrase like intact and then maybe translocates, because that's going to capture that second piece of that information, which is, when it's inside the nucleus, there isn't as much degradation going on, right? Yeah. Because it's accumulating in there. The next piece of text, right? That other part about Groucho and WNT signaling and all that other stuff, talks about what's happening inside the nucleus. And again, I wouldn't spend a ton of time focusing on that because it seems to be breaching into this biochem territory, because receptors, co-activators, gene expression, that's a biochem section, right? That's where that information is probably going to be asked about more. But I would probably highlight the name Groucho, not because it's funny, but because it's the name of a co-repressor. So if there's a question that asks about it, you'll know exactly where to look. And then you can also probably highlight like acts as a co-activator to remind you that beta-catenin is acting as a co-activator and Groucho is our co-repressor, right?
Yeah.
The other thing I would highlight is like that last piece, we get information about what happens in the absence of signaling. So I'd probably say absence of Wnt signaling and then cadherins. Right? Towards the end of that, everything else is kind of like whatever, right? It's just like adhesion, junctions, blah, 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 blah. That's biochem stuff.
Yeah.
But towards the end of that paragraph, we get another piece of information about degradation, which kind of ties in with what we talked about in the beginning of that paragraph. So I'd say like not associated with cadherins and then degraded again, right? Because again, the theme of degradation seems to be coming up a little bit in our figures as well as our text.
Yeah. Wow. Okay.
Does that feel better? Does that feel worse?
No, not at all. It doesn't feel any better.
Okay, that's fine. But again, like, I think if you are the type of person who, when you're reading this paragraph, you start to feel super overwhelmed, that doesn't necessarily mean you have to do a full, thorough highlight there, right? You can just pay attention to, all right, this is information about degradation and beta-catenin.
Yeah.
You can go back to it if you need it, right?
Yeah.
So I went through the highlighting for thoroughness because this is a podcast and I want to make sure that everyone is highlighting appropriately. But if you encounter a passage like this and you feel overwhelmed, like, don't feel like you have to do that, right? Just know what information is found there so you can go back to it and do your necessary like analysis when it comes up.
Yeah. All right. And then when figure 2 is just kind of a picture of everything the paragraph just talked about.
Yeah, I think it's nice because figure 2, I wouldn't spend a ton of time on it, but if you didn't know what figure paragraph like that was talking about, like you couldn't really understand it, it was too hard or dense to understand, you can look at figure 2 and see, yes, it displaces our Groucho.
Mm-hmm. Yep, exactly. All right. So, which of the following is most likely to cause more stress and anxiety for Dr. Gray? Which of the following is most likely to be the precursor of the group found linked to the N-terminus of the Wnt protein? Wnt protein. All right. So which of the following is most likely to be the precursor of the group found linked to the N-terminus? All right, so I'm already thrown off because now it's like the precursor of the group found linked. Okay. I don't even know how to say all of these groups anymore, so I'll let you read this question.
I'll be honest, I don't quite know how to read it either.
Good job.
But what we have is a bunch of NH2s stringed to a carboxylic acid group at the end. That's answer choice A. Answer choice B has a bunch of carbon hydrogen chains, an alkyl chain, if you will, bonded to an O, bonded to another carbon, which will tell you that it's a specific functional group, which is an ether, right? We talked about that in the last episode, but that's an ether strung to a whole alkyl chain.
Yep.
Answer choice C is just C6H6, and answer choice D is an alkyl chain bonded to a carboxylic acid group.
Yeah, I have no idea. So I'm trying to think about where did we find this, right? The Wnt protein, what it looks like. We talked about this first paragraph. We highlighted fatty acid chain, right? We highlighted here fatty acid chain attached to the N-terminus, which increases their binding to cell structures or surfaces. So I'm assuming the answer is based on this, like something about that. So which of the following is most likely to be the precursor of the group found linked? So what's the precursor to a fatty acid chain? I'm assuming is what it's asking. And I wouldn't know how to answer that, but I'm assuming that's what we're going toward.
Yeah, so I think when it comes to precursor, I wouldn't take it super, super literally there, just because of the fact that we're asking about like what group can ultimately turn into whatever is bonded to our like fatty acid chain. So all of the answers that you see here are really, really basic versions of different structures. And so those are all going to be precursors. So you can just use the fact that it's a fatty acid and come up with the conclusion based on that.
Okay. All right. So what's the answer? Because I don't know.
Okay, great. So in terms of our fatty acids, right? Fatty acids are just straight up long alkyl chains that terminate in a carbolic acid group. So answer choice D is going to be our answer because it's one of the simplest structures of a fatty acid that you can see. The reason why it's a precursor and not necessarily the actual group is because you can modify it to add a bunch of other stuff to it, but that bare bone, that like backbone of the structure is going to be that alkyl chain with the carboxylic acid towards the end. So that's going to leave us with D as our answer. If you weren't sure, if you had no idea how to answer this, right? Answer choice C is the structure of a benzene. So that's something that we have to be familiar with in terms of like MCAT knowledge. So MCAT students, you should be able to eliminate C. Answer choice A, I would also eliminate because I'm going to be honest, I have never seen a structure where it's just a bunch of NH2 strung together. Like that doesn't really ring any bells for me. So I would probably eliminate that because it doesn't seem very familiar to what's present on the MCAT.
Mm-hmm.
So that gets you to that 50-50 between B and D. And then you can start thinking about, all right, what's the difference between B and D? B has an alkyl chain attached to an ether, while D has an alkyl chain attached to a carboxylic acid. And because we're talking about a fatty acid, there's got to be an acid in there.
He's got to be.
Yeah, so that can get you to D if you weren't exactly sure. That's sort of a way to deduce how to get to that answer.
All right. Easy. Just simple as that. All right. So I'll read question 20 here. 32P has a very short half-life of 14 days and decays into sulfur as shown below with a nice little diagram. It says 32 over 15P goes to 32 over 16S plus an electron. This nuclear reaction is an example of A, alpha decay, B, beta plus decay, C, beta minus decay, or D, positron emission. So, yeah. So radioactive kind of decay here. I don't remember any of this. So positron emission, like positron emission doesn't sound right because looks like we're just giving off that electron there, which is not a positron. So maybe get rid of D right off the bat, and then look at A, B, and C. B and C are both beta minus, beta plus, so that gets to their opposites. And so I'm going to stay attracted to B and C. And then the question potentially is, what does plus mean? What does minus mean? Now, we went from 32 over 15 to 32 over 16, whatever that means. I don't know. And then we lost an electron or there's an electron there too. So does the minus mean we lost an electron? Does the plus mean we went from 15 to 16? So many potential struggles there. Does plus and minus refer to the periodic table and where we're going from the phosphorus to sulfur? So I'm going to pick C and move on just because I don't want to think about it anymore and just keep going.
Woo, you got it. C is the answer. And I think one thing I will tell you is that beta plus decay is the same thing as positron emission. So if you didn't know which one the answer was, but you knew that beta plus decay and positron emission is the same thing, I'm pretty sure the plus refers to like the sign of like the E whatever, like E minus is beta minus, E plus, which is a positron, is beta plus. I don't know if that's 100% true, but that is my understanding and how I remember the difference between beta minus and beta plus. So if you knew beta plus and positron emission were the same thing, you could eliminate B and D. And then using your principle of like opposites, you can get to C as your answer. But for listeners, for you guys to be aware of, the types of decay, I'm going to be honest, I don't know why the MCAT loves testing you on this. I have some ideas, but like, who knows really? So it is something that you need to know. And the best way to do it is just remembering and sort of memorizing almost what happens during each one. So in alpha decay, we have the emission of what's known as an alpha particle, right? Makes sense. And an alpha particle is the same thing as a helium nucleus. So 2 protons, 2 neutrons. So from there, because you know 2 protons and 2 neutrons are being emitted, you can tell that when there's alpha decay, you're going to have your mass number go down by 4 and your atomic number go down by, right? So since that didn't happen, we can eliminate A as our answer. And
say that one more time. You broke up just for a split second. Where did the numbers go? 4 and what?
Yeah, sorry about that. So for alpha decay, our mass number would go down by 4 and our atomic number would go down by 2. And we can tell that because we have 2 protons and 2 neutrons. So 4 things in total getting emitted. Okay.
And the mass number is what number? The 32?
Yes.
Okay.
Yes. The mass number is going to be the one on the top. Generally, it's going to be bigger. And the atomic number is the one on the bottom.
Got it.
Yeah, so that's pretty much it. That's all you need to know. The 3 types of decay that you need to know are alpha decay, beta minus decay, and beta plus decay. And gamma emission, I believe, as well. Gamma emission is one of the easiest ones to recognize because there's actually no change in atomic mass or atomic number because the only thing that gets emitted is a gamma particle, which, I'll be honest, don't really know what that is.
Poor gamma. Nobody gives respect to gamma.
I know.
All right.
Yeah,
so, I don't know about doing great, but I got it right.
Listen, you use deduction to the best of your ability. If you knew that beta plus and positron emission were the same thing, you would have gotten that easy.
Okay. Now everyone else knows it.
That's true.
All right, 21 for you.
All right. A scientist concludes that the phosphorylated beta-Catinin is the form that is degraded. Why do the experimental results support this conclusion? A, the levels of nuclear 32P decrease faster and remain lower than 32P levels in the cytoplasm. B, the levels of nuclear 32P increase over time while cytoplasmic 32P levels decrease. C, cytoplasmic and nuclear levels of 32P both decrease over time. And D, cytoplasmic levels of 32P remain constant.
Phosphorylated beta-Catinin is the form that is degraded. And we go back to this third paragraph that talks all about degradation of beta-Catinin. Why do the experimental results support this conclusion? And so, phosphorylated. So we have figure 1, results of radioactive phosphate assay, looking at the signal. The levels of nuclear phosphorus decrease faster and remain lower in the nucleus than they do in the cytoplasm. And we know that the beta-Catinin is degraded in the cytoplasm. Okay. The level of nuclear stuff, this phosphate, P-labeled phosphate is levels increase over time with cytoplasmic levels decrease. Okay, see cytoplasmic and nuclear levels of they both decrease over time, so that one just doesn't, again, logically that one doesn't make sense to me. And then this one, cytoplasmic levels remain constant, again, doesn't seem logical, again, knowing that that's what's degraded in the for the beta-Catinin, right? All right, so the level decreases faster and remain lower. So nuclear level, so inside, decrease faster, remain lower than in the cytoplasm. That doesn't make sense because it's going in, it's working hard. It's in the cytoplasm where things are being degraded and we're losing that beta-Catinin. So I'm going to go with B.
Interesting. Okay. So unfortunately that isn't correct, but I think that the one thing I'll turn you to here is for answer choice B, I would ask you, does it match what our figure shows?
Figure 1 or figure 2?
Figure 1.
Figure 1. So we see cytoplasm staying higher than the nucleus. So no, it doesn't.
Yeah, exactly, right? Because we see that we're being told in answer choice B that levels of nuclear 32P increase over time, which isn't true, right? It decreases and eventually gets to 0. So although the logic of B could make sense, because it doesn't match what our figure shows, it has to be wrong. Right? So like for questions like this, I'll be honest, the explanation for why answer choice A is correct is really convoluted, really complicated, right? As someone who understands the MCAT relatively well at this point, I was still like, oh my goodness, that is something, right? However, the reason for why B, C, and D are wrong are very concrete. So for this type of question, especially when they ask about an explanation for something, that's usually what it involves. It usually involves answer choices that are either scientifically incorrect because of what we know about MCAT knowledge, or things that directly contradict the results, or they are things that don't really answer the question, right? So answer choice C is like a classic, like, yeah, they both decrease over time, but that doesn't explain what the question is asking us to explain. So we can eliminate for that reason. Does that make sense?
Yes. And I don't like it, but it makes sense.
Yeah, it's not fun. It's not the best. And I think that's what I sort of mean by when we have questions and passages that are really complicated, the answer choices are more likely to involve you eliminating a lot more because the reasons for elimination are going to be a lot more concrete here. Yeah. So for answer choice A, for those of you who are curious, the reason why it's correct is because in our passage, we're told that beta-catenin accumulates in the nucleus and degrades in our cytoplasm, right? And in the figure, we see that the signal from our radioactive phosphate drops off for both cell mixtures, but drops off a lot sooner and reaches nearly zero in the nucleus, right? But in the cytoplasm, there seems to be some sort of steady state. So those two pieces of information combined tells us that the beta-catenin that's in the nucleus isn't the one that's phosphorylated. It isn't the one that contains that like fractional P signal emitting like radioactive phosphate. And so because of that, A is going to be correct because since the beta-catenin that's intact has the unphosphorylated one, the phosphorylated beta-catenin is going to be what's degraded. Again, super complicated. A lot to think about. If you didn't understand that, that's totally fine. I don't think the MCAT really expects you to understand something as complicated as that based on a figure like this and a passage like this. I think they expect you to understand why B, C, and D are incorrect.
Okay.
How do you feel?
If you say so.
I'm not going to, we just met, but I'm going to ask you to trust me on this one.
I got it. I trust. I don't understand, but I trust. I struggle when on questions, and again, it's very short amount of time. We could sit here and talk for 20 minutes about it, and then I go, okay, I got it. I'm a very logical person, and it's just I can't logically think about it as we're going through it for that specific question. Just there's something off about it still to me, because I think that where I struggle is going back to this paragraph. Mm-hmm. We know that things are degraded in the cytoplasm, mm-hmm. and not in the nucleus. Mm-hmm. And so when we look at, okay, things are being degraded, then I want the cytoplasm to decrease more because that's where things are being degraded. That's the logic that forces me to be and why it's taking me too long to understand A.
Yeah, no, I totally get it. I think the thing to be aware of, though, is that in general it's degraded, right? But if you look at the figure, the thing that is different there is that the signal is only of the phosphate, the phosphorylated like P, right? Because that's the thing that's radioactive. So the fact that cytoplasm has more degradation, but it's higher than the nucleus, sort of tells us that there is some sort of preference of what's going in the nucleus versus what's not. Does that make sense?
Mm-hmm.
Yeah, that's the main logic of that question.
Yeah. All right. Question 22. Is this yours or mine?
We can make it either one. I think I read 22, 21, so I think it's your turn, but I'm happy to read it if you want me to.
All right, let's rock and roll. I'll do 22. In vivo, PO4 3- molecules, whatever the name of that one is, utilize proton-coupled transport mechanisms to enter the cell. Which statement explains why this is necessary? All right, so this seems like this has nothing to do with the passage, and it's more just like, hey, do you understand transport mechanisms and why things are the way they are? All right, so A, what's PO4 3 minus? What is that?
I think it's inorganic phosphate.
Yeah, just phosphate. So phosphate is hydrophilic. Phosphate is hydrophobic. Or C, the cell membrane is hydrophilic. Or D, the secondary active transport mechanism conserves ATP. All right. We love conserving energy as an animal, as a Homo sapiens. So conserving ATP is always good. And so it's like, okay, maybe that's logical. The cell membrane being hydrophilic and PO4 being hydrophobic, or hydrophilic rather, like those two are like the same to me. Like they can't be both. I don't know. There's something about these being both that I was like, they're both hydrophilic. That's off for me. So I don't know why, but I'm left with B or D. Utilize the proton-coupled transport mechanisms to enter the cell. I'm going to go with D just because let's save our energy. We're going to conserve ATP and go from there.
Okay. So unfortunately that isn't right. I feel bad. I feel like my reaction when you first do it, I feel like I do this in classes too. When the class doesn't get the answer right, I'm like, interesting. And they're like, yes, we got it wrong.
Yes.
But the rationale for this question that I would probably implore you to use here is it's another explanation type question, right? So we need an answer that logically explains why something is possible, right? So for answer choice D, the idea of secondary transport mechanisms conserving ATP, that's a true statement, but it doesn't really explain why you need to have that transport in the first place. Because when we want something to get into the cell, there's going to be transport that's facilitated by proteins, or there's going to be simple diffusion, right? Those are the two options. Then within proteins, there's a whole bunch of other, breakdowns that you can think of. But it's going to be either simple diffusion or passive transport or active transport. Like those are the three things. So the answer choice that we need to choose here is going to have to explain why inorganic phosphate can't just travel through the cell. Easy peasy lemon squeezy. Like, why do we need proteins there in the first place? That's what we need.
Yeah.
So although D is a true statement, it doesn't explain why we have those coupled transport mechanisms in the first place. So for that reason, it's going to be incorrect.
Got it.
And I see you highlighting.
So it's one of those questions where it's like, that's not the most correct answer.
Yes, exactly. And I think these explanation questions can be really tricky because you have to be able to understand that just because a statement is true doesn't mean it's going to be the answer. It has to link to what the question is asking us to explain in the first place, right? So between A, B, and C is also incorrect because the whole thing about the cell membrane, like biologically, is that it's a phospholipid bilayer, right? So it's like hydrophilic on the outside, hydrophobic on the inside.
Yep.
Just to say that the cell membrane is hydrophilic would be contradicting what we know about science, right? So that's going to be wrong. And between A and B, which one do you think is going to be our answer? What are you thinking?
That's a very good question. I think it's going to be hydrophobic.
Unfortunately, that's not the case. But the main reason for that is because if it was hydrophobic, it would be able to travel through the little phospholipid tails in the middle and go through easy peasy. Hydrophobic things are the types of compounds that can passively diffuse through a membrane. Hydrophilic ones are the ones that require some sort of transport protein, right? And the other thing that you can remember is anything that's charged is going to be hydrophilic more so than hydrophobic, right? Anything that's charged super negative, that's going to be more likely to be compatible with water. So answer choice A is going to be our answer for that reason as well.
Got it. Yeah, I knew that. I just wanted to get it wrong so that you could explain it to people.
Right, of course.
Okay. I got completely demolished by this passage. And so
This is hard.
Yeah, again from a mindset perspective, because I like going to mindset. I think there are free points in mindset things. For an average student who's scoring average on an MCAT, this could throw them off for the rest of the Chem Phys section, all of the cars passage, maybe even through lunch into biochem. How do you shake it off outside of your woo-woo breathing techniques that you were talking about earlier?
Yeah, I think one of the biggest things that I like to think about is that every question is weighted evenly and every passage is worth the same. So just because there's one passage that completely messed me up, that doesn't mean I'm going to get every single other question wrong, right? So in terms of devoting my mental energy, I would say, all right, let's forget about that one and let's try and ace the next one. Let's try and make the most of the stuff that I do know and leverage that whenever possible, right? So like treating every passage as an independent entity, saying that just because this passage is hard just means the next one's going to be hard. And that doesn't mean that the next section is going to be incredibly difficult, right? Recognizing that they're all sort of independent of each other is going to be really important there.